Well, hopefully these videos will help you understand a little bit better how to graph these trig functions using the phase shift. It's kind of our last thing we have to understand how to do. And I put the steps here just in general in graphing trig functions. Find the period, and then plot the period, find the 5 key points, draw the curve, and then do your phase shift. Do your shift left, right, up, or down. Okay, and so that's what we're going to do here for number 1. We're going to do for all three of them, 1, 6, and 11. As you can see here, without the phase shift, we're going to, let's just do this. Y equals A times the sine of B x minus C plus D. That's the general form, and we know that the period is always, for the sine, cosine, secant, and cosecant, it's always 2 pi divided by the B. Okay? Well, we know that the period here is 2 pi. 2 pi over 1, which is 2 pi. So in general, if we want to relate how to graph the sine function to all the other ones, in general we have 2 pi. Okay, so we put the period right there. As soon as we find the period, we plot it right there. It says plot the period. And it goes right there. And then how do we find the key points, the 5 key points? Well, we divide the period in half. 2 pi divided by 2 is 1 pi. Pi divided by 2 is pi over 2. And then halfway between pi and 2 pi, and sometimes I like to look at a unit circle. It's easier sometimes. You go, you can find the values a little bit better. 3 pi over 2, and we know, again, this is 2 pi. So halfway between pi and 2 pi is going to be that angle, 3 pi over 2. And the angle in a unit circle, which is exactly related to the real number in between pi and 2 pi. And so finding the 5 key points, we already know what it looks like if we plotted, if we made an XY chart for y equals the sine of x. Again, we're not going to be drawing, doing the shift left, right, up, or down yet. We're just going to plot the points as if it were y equals the sine of x. And if we pick the first part of our period, 0, we plug in 0, y equals the sine of 0, which is 0. Okay, and so we could, what color should I draw this in? 0, 0, and then if we plugged in pi over 2, we'd get 1. Okay. If we plugged in pi, we'd get 0. The sine of pi is 0. The sine of 3 pi over 2, we know that to be negative 1. Sorry, yeah, negative 1. And the sine of 2 pi is equal to 0. So we're back at 0. So the sine graph looks like this. We already know that. We already did that in the activity. Okay, so the sine graph comes down, goes up like that. So I'm drawing it dotted because this is not our final product. Okay, so all we have to do then to draw our final product is to take each of these points and shift them. Then notice that we're graphing the sine of x minus pi over 4, and the phase shift is whatever is being subtracted from the x. Okay, so the pi over 4, that means we're going to shift it to the right, pi over 4 radians. So every point gets shifted to the right, pi over 4. So 0 plus pi over 4, pi over 2 plus pi over 4, that gets shifted over there. So this point moves to the right, this point moves to the right. The 5 key points are just going to move to the right, pi over 4 radians. Okay. So each of these points, each of the points on the purple dotted graph gets shifted to the right, pi over 4 radians. So 0 plus pi over 4. Then you have to look here. You have to label your graph. What's halfway between pi over 2 and pi? Well, that's 3 pi over 4. You have to label these. This is the important part. Halfway between pi and 3 pi over 2 is our 5 pi over 4. And then halfway between 3 pi over 2 and 2 pi is our 7 pi over 4. And if you notice the pattern, 1, 3, 5, 7, and then that would be 9 pi over 4. So we just shift it to the right. Pi over 4 radians. And that's our final product. Okay? That's it. So that's the answer to number 1. That's going to be your easiest one when you take a sine or a cosine graph, shift it to the right or left, and you have no up or down, and you have no amplitude changes. Amplitude is just 1. So I'm going to stop there and then start the new video with number 6.